It's a real honor to be in the group of privileged people invited to say a word to these really nice occasions. So the initial title that I wrote quickly was François in Belgium. Then I figured out that François hasn't spent so much time in Belgium, and maybe I will try to explain why at the end. So I had the feeling it was probably better to phrase it François for Belgium with a modern acronym. And I will again try to explain why. So it's not a presentation about, there will be a little bit of science, but not that much. So I went back to my emails to figure out when it started, but yeah, changing from PC to PC to Mac, obviously the mail disappears sometimes. So I couldn't find the dates, but I remember really well where the journey started and when I first met François. So our former colleague, Jean-François Ledan, in Belgium, was a wheat and maize ecophysiologist. He was a visionary person. He was the first owner of a personal computer in our university, just to let you know that it must be someone. He was really much interested in crop model. He had written an Excel version of Ceres maize. At the end of his career, he was making maize virtual plants also built from Excel. He was passionate of culture, teaching on all continents, which is why he wanted to have everything in Excel, because you have Excel everywhere in the world. He was also speaking more than 10 languages. So, yeah, kind of a person. And then Jean-François met François, or invited. I don't know exactly how you came out to be in Louvain-la-Neuve, but Jean-François Ledan was aware that there were 3 young colleagues. Yeah, these are the youngest picture that I found of François Chaumont, Mathieu Javot, and myself. 3 young colleagues around, not talking to one another in any way. And Jean-François said, François, can you go and discuss with these 3 guys? And François spent an afternoon with François Chaumont, who is a molecular physiologist working on maize aquaporins, with Mathieu Javot, who is a soil hydrologist working on soil plant hydraulic modeling. And myself, I was interning from Drosophila to plants, quantitative genetics, and with an interest in underground ecophysiology and root architecture. And at the end of the day, François came back to us 3 saying, how come that you don't know each other? You have such an array of disciplines around the same place, La Place Croix du Sud, for those who know it. And well, you must do something together. And since then, we haven't stopped trying to do more things together. And this is something that we certainly owe to you, François. So I have 3 stories, very short. One is François meets François. The first is François Tardieu, and the other one is François Chaumont. So this is the language that François Tardieu was speaking. And you have seen this picture certainly today several times, with a simplified representation of leaf growth with essentially resistance and water potential and fluxes. And on the other side, François Chaumont, who doesn't know essentially what is a water potential at that time or a resistance, but he's a really good expert to quantify the expression of aquaporins and things like that. And so François is a man of vision. You said it before, and definitely all what is there is really useful to characterize or understand a little bit what's happening in those resistance. So the main thing that you brought to François Chaumont can be exemplified with some papers that you made together, in which there are keywords that were completely unknown to François Chaumont before he met François. It's difficult, François Chaumont, François Tardieu, Jean-François Ledan. So leaf elongation, hydraulic conduction, transcale approaches. And then at the end, there was this story of Laurie Mestrio, where François put the finger into saying, I'm not going to quantify the expression of aquaporine in 50 genotypes, but maybe 250 genotypes. So that was a big jump, and François would never have dared to do it without your support. So in a few words, that's what François wanted to tell to you. It has been very inspiring and stimulating for me to interact with you. Our collaboration has led to very interesting discussions between an ecophysiologist and molecular biologist with a language that was sometimes difficult for me to understand. It allowed us to interact with many people with complementary expertise, with whom we continue to collaborate, in particular the gang from Le Moulon. And I was impressed, well, François was impressed by the way in which you led the DROPS project from its inception to its completion, with efficiency, vision, and relevant interventions. Then François met Mathieu, and so the point now was going back to this little scheme of the model. There is a soil resistance in there, and that soil resistance is something that François is, that Mathieu is expert of, and François suggests that we should write something together, bringing Mathieu into the literature of plant scientists, and it's something we have tried to do, and I think it has been working really well. So there was this sentence of Passura about where the soil water is actually going to the plant, where is the control? Is the control in the roots? Is the control in the soil? And so Passura was concluding when the soil is wet, it has little influence on the uptake by the plant. When it's dry, it has a large influence. And when it's neither wet nor dry, the extent of influence is a matter of controversy. And you will all agree that if you start on these grounds, you have very solid foundations to collaborate with François. So I am not going to explain this graph. Working François and Mathieu together was a confrontation of different ways to model the things. With a first side of François, which is focused on the plant, but the soil is there. And the other side of Mathieu, which is focused on the soil, but the plant is there. And another difference was that Mathieu had engaged into the use of functional, structural soil plant models. So he had a complete mock-up of the plant, a complete grid representation of the soil, and his model was able to represent or compute fluxes of water within the soil, within the root. And so at a time where plant scientists would compute the weight of a pot and say that's how much has been transpired, Mathieu was looking at where does this water come from, and it's probably not the same thing in terms of a consequence for managing the soil water budget. So I think that's something that has been attracting you, that the availability of a tool and the person who did the tool was more important than the tool. Being able to link transpiration, soil properties, plant architecture, and hydraulics, all that in the same toolbox, with parameters that you can measure, model parameters. And this was an example that the role that the plant can play in the distribution of soil water, keeping the same root architecture, but only changing the ratio of xylem conductance to radial conductance, you can have a dramatic effect on the distribution, the vertical distribution of water uptake. And then came a tall guy, Valentin, who is there, followed by Félicien, who were able to bridge an important gap between Mathieu and François, was the number of parameters. Because the R-SWIMS model of Mathieu is a kind of a gourmand, we would say in French. And okay, there is a little shift in the colors. So Valentin was actually able to show that you can simplify this complete 3D representation with two concepts. One is what they call a standard water uptake, which is how the water uptake would be distributed if the soil was uniform. And that is essentially driven by root architecture. And the other term, which is how the heterogeneity in the soil, which is leading to difference in water potential, will actually create movement of water within the soil. And this is largely driven by soil properties and hydraulic properties of the plant. So I'm going to stop that story, but still wanted to show one of the results of those simulations is that if you take into account the possibility of this compensation of fluxes within the soil, which is what we don't consider when we have a pot, you actually predict very different patterns of transpiration. So that would be the day-night transpiration during a dry down experiment. If you allow the vertical redistribution, and if you do not allow for this redistribution, if you consider the soil is uniform, then after here 4 days, you should have a very abrupt decrease of transpiration. And so the fact that what we observe usually is more the first suggests that compensation was an important term to consider. And then François met me. And so that was François' PhD was about roots. So normally he should know what it is about. He knew better than me. And at that time, I was starting to play with the technology to try to image and evaluate. Can I get, well, whatever. Root system architecture for here maize plant for a large number of plants. So it was a bit before 2010, before the start of the DROPS project. So that was a different kind of confrontation. Okay. So between François, who, okay, roots, I'm done. You're talking a little bit too much about it. And myself, at that time, focusing on trying to get those parameters that would allow me to do kind genetics and things like that. So, but within the framework of DROPS, you enable us to actually touch GWAS through the contact with Le Moulon and the material that you had, and also to do this really nice inclined field experiment in Italy. And the conclusions where it depends again. On the one side, we had this GWAS that was less exciting than the one that was shown before, in the sense that whenever we tried with all the root trays that we had, we couldn't get any really good and nice hit. And on the other side, while growing the same genotypes along a slope with a horizontal water table, so we were able to reveal the different colors correspond to different positions, extremely different response in terms of yield, with one genotype, MS153, and I think that Andy showed later that it's a deep-rooted guy, was completely insensitive of being able on the top or below on the downside of the slope, while pH 207 had a really... So on the one side, it must play a role, and there are differences but on the other side, the genetics in our phenotyping platform was not revealing anything. So I'm concluding with an attempt to model François' impact in Louvain. So you could say that the potential of what you brought to us was actually a potential that you have been smart enough to see, times a capture that you have been smart enough to pick, and then a Belgium use efficiency. And I think you have been smart enough to get us where we are today and to help us and guide us in that. And there is a feed-forward stuff, because as we were gaining benefit from that, we were better in our potential, we were better in being captured, and also better in being converted into something useful. Well, that's at least what I hope. No, François, it has been hard to get you in Louvain-la-Neuve. I think that your Ambitions or exigences in terms of architecture is not probably, yeah, that's the beautiful church of Louvain-la-Neuve. It doesn't look like, okay, Lorenz, I know you are somewhere. Okay, you don't like Louvain-la-Neuve in terms of architecture. You say that to me a few times. But we have some secret weapons. So we hope that there will be some opportunities to see you in the future, maybe in a different context. And I would like from the group here to a big thank for your inspiration, for making this happen. Normally this was split in 3. And yeah, that's UC Louvain family. And a personal touch, maybe. When I did my PhD on Drosophila, and then I moved to plants. It was not an easy shift, and I was hoping that Jean-François Ledan would be my scientific father. He didn't want to play that role, and I think maybe without knowing, you have played that role a little bit for me. So thank you very much.